Okay, I think we can start. Probably I scared a lot of people last time with a lot of theory. But the idea behind this subject was actually having first 5 hours of some kind of theoretical background, theoretical introduction, and the next two um, classes, tomorrow and on Friday, will be more practical, definitely. So let's start with the short review of what we've done previously. I will share my screen. Okay, maybe here and now. Okay. I hope you can see my screen.
Yes, it's fine.
Thank you for confirmation.
You're welcome.
So problem solving, decision making with artificial intelligence, machine learning methods and tools. We haven't mentioned a lot of artificial intelligence and machine learning yet. Because we've started with the system theory, system analysis, system modeling. This is the point where we probably finished, because we defined what system is as a sum of elements with connections between them. The elements have their attributes and actions, and all of the elements of the system have their individual goals, but in the same time, they should be focused also on the system goal. There is a flow between elements within the system, but also outside of the system, and what the flow is: energy, information, and materials. We also talk about the synergy effect, which is the characteristic of a system that says that system as a whole is more than its elements separately. So using a system or being within a system gives us something more than we've got as individuals. We defined different types of system in taking communication between system and its environment as a criteria. We define subsystem and suprasystem, the presentation of the system in the form of black box and white box, some other classifications of systems that we discussed, the complexity of the system. We also mentioned, maybe I will start, it will be better if it will be, yeah, maybe from the current slide. Oh, sorry, not this view. Not this view. Okay. Now it should go as it should. The theory, starting from ancient times through the development of basically information technology and the beginnings of information technology, in which system theory is now widely used. We also briefly mentioned artificial neural networks in this historical background, which were very important part of systems development. The ways of describing a system, like mathematical equations, graphs and nets, formal automata, Markov chains. We also mentioned ontologies as a way of storing knowledge in computer systems. Kohonen maps, hierarchical self-organizing maps, genetic algorithms, system analysis, and definition of information systems. So from the general definition of system theory, which is not only used in information technology, but also in other areas, as we could see, natural sciences, social sciences. We moved to information systems, so something that is connected to information technology. So the potential area of usage of artificial intelligence and machine learning. We defined the goals of information system, the components of information system, and we definitely mentioned project feasibility. So if we want to introduce new information system, what we should do, and we started with feasibility analysis in 4 areas: economic area, operational, schedule, and technical area. We mentioned system development life cycle on a few examples which had a lot of elements in common. We mentioned different approaches to system development, like waterfall model, structured approach, object-oriented approach, and agile approach. We've got it all here. And we also mentioned organization as a system, because information system always is designed to support organization in its actions. So it's something that should help organization, its employees, to achieve organization, but also their individual goals within the scope of the system. So we can say that organization is kind of system because it consists of entities with their goals. Organization has its goals. So definitely we can say it's a system, but it sometimes, even quite often, needs this information system, so this support in a form of computer program in achieving the goals. And seeing organization from different perspectives definitely shows us a different picture of this organization. So each element in the organization have different perspective and sees the organization from this perspective. And here we see information system as a subsystem within an organization system. So it helps with achieving the goals. Short, not so short, but okay, definition of agile approach to software development. One of the more popular approaches now for developing software. With its main feature, communication, simplicity, feedback, and courage. We definitely compared Agile to waterfall model, managing system project. Okay, project management. We defined what is a project and what is project management. We defined project constraints like a scope, time, resources, and money. And we defined the elements of project management like project planning, scheduling, monitoring, and reporting. We definitely discussed, this model we already discussed. And we probably, finished somewhere there. Standard normal distribution. Okay. Resources constraints in project management. Okay, so this is the point we start today. We will finish some topic with the system theory as the background for the topic. Then probably we'll make like 5-10 minute break, and we will move on directly to problem solving, decision making within this topic. This is the plan for today. And this is quite important part if we are talking about some introduction to problem solving and decision making, because to solve problems, to make effective decisions, we need resources to be able to make those decisions. But in this case, we are talking about scheduling within the project and resources that we have in our disposition to create the system. So the elements that we need to take into consideration are tasks that are to be done, task dependencies, so which task should be done after which one, and resources that we have, money, people, materials. So the initial step is performing CPM or PERT analysis. We mentioned them on previous slides. Check the resource availability and correct the schedule due to constraints. For example, in this case, we see here some resource conflict that must be resolved, because we cannot have anything above this dotted line here, and we can see that we actually have it. So we've got, this is our level of resources. This is the timeline. And here we've got some resource conflict. So we need to move some tasks to fit those tasks within the scope, but it influences the time that we need to realize this project. It will extend the time, so we need to check if it's possible. Maybe it will influence other tasks within the project or the final deadline for the project. So this is something we need to take into consideration. Okay, I think that we've got wrong table because it's not translated. But we already seen this table with the correct headers. Action, time, preceding action, and the resource that is needed. So we've got CPM chart, we already seen it. So this is the initial analysis that we need to perform. We need to check for the conflict, we need to check the critical path and see what we can achieve with this. Gantt chart with resource requirement information. And we see that here we've got some potential problems that we need to move some tasks by 1 or even 2 days. During project realization, when we've got the schedule, that we prepared at the beginning. We need to monitor the project activities to check if we are following the schedule or maybe we are behind the schedule. So in here, we've got different activities within project. They are usually layered from the earliest to the last ones, like conduct interviews, administer questionnaires, read company reports, analyze data flows, introduce prototype, observe the reactions, perform cost benefit, prepare proposal, present proposal. So this is some project that the organization is analyzing. And we can see that with some tasks, we are in time. Completed activities, we are here. So we've got 3 completed activities. With some activities, like analyze data flows, we are ahead of time because we've got week 9 and we already completed activities that were planned for even week 11. But with some tasks like introduce prototype, we are behind the schedule. So this is information for management that there can be some problem with this task. So it requires a closer monitoring. Similar analysis, but in the form of table. We've got costs, we've got percent of stage completion, we've got actual costs, so we also can monitor if our costs exceeded what was planned. So during the whole process of system development, it is important to monitor schedule, costs, because it influences the final outcome of the project. While developing new system, we need to seriously take risks into consideration. Usually, information systems are not the small ones. They are usually quite big ones. So introducing new system, especially using new technologies, requires taking some risk. And risk management is part of managing a project. Here we have a fishbone diagram that we can use to identify all the risks, the possible risks within the project. So what can go wrong? In terms of quality, cost, scope of the project, time, designing, testing, coding. So what possibly can go wrong? Like, for example, customers not satisfied with the interface. So we developed some interface of the system, but customers are not satisfied with it. Cost, we already mentioned managing, monitoring the stages of developing the system, the costs, because it may occur that for some reason we will exceed the costs that we initially discussed, and it is also the risk for the project. Time, schedule slips, not only cost, but also some time related issues. Testing, system fails tests. It may happen. What to do in this situation? Communication breakdowns. some misunderstandings within the team or also with customer. So a lot of factors that may cause that our project won't be successful. And we have to take these risk factors into consideration. One of the tools for this type of problems is risk matrix. So we have the impact on the project, like negligible, minor, moderate, significant, severe, and likelihood of occurrence of each type of risks, from very unlikely to very likely. And in this case, we've got like exact example with exact data. So insignificant, minor problem, easily handled, minor, some disruption, damage equal to $500,000. Quite big amount, but it needs to be related to the value of the whole project. Moderate, significant, time, resource required. Damage equal to about $1 million. Majors, operations severely damaged, damage equal to $10 million. Catastrophic, business survival is at risk, and damage equal to $25 million. This is like one example. Especially the money values, they are not like the same for all organizations. Depends on the size of the organization. But in this case, these are the thresholds. And probability, likelihood of occurrence, rare, less than 3% of chance, unlikely 3 to 10, moderate 10 to 50, likely 50 to 90%, and almost certain over 90%. So having this risk matrix, we need to evaluate if the whole project is worth taking the risk, if as an organization we can afford it. In risk management, using this risk matrix, we identify the potential risks and we analyzed which can mostly influence our project. If we know this and if we accept the risk levels, we need to plan action that we can take in possible situations, implement them, measure, control, and monitor. So within risk management is not only the identification of possible risks, but also developing strategies to overcome possibly dangerous situations and to constantly measure, control, and monitor how big is currently the risk and what we can do to prevent it. As I mentioned before the previous section of the presentation, one of the very important parts of problem solving and decision making using information system is data gathering. So managing the project is also about making important decisions. So this is still connected to the topic. But I think this part, techniques of data gathering, are even more important for our subject, because to make decisions we need data. Okay. How can we gather data? Interviews, joint application development, rapid application development, and surveys. These are the potential sources of data in information systems. Considering interviews, communication person to person. If we want to gather information via interviews, we need to be prepared to conduct the review. So we need to read available materials beforehand, establish the objectives, what we want to achieve, decide what is our target group for interviews, and design this interview structure. So definitely person-to-person method for gathering data. Definitely very effective, but also very it generates a lot of cost, let's say, in case of both money and time. But when we have like the person we are interviewing in front of us, we can always ask some supportive questions, to gain some additional information, to clarify something that can be unclear for us. So interviews are, or were, mostly in the past, but we still use them, a very effective source of knowledge. When we are preparing questions for the interview, we may use some structures to analyze how to prepare questions for interview. Basically, this structure, pyramid structure for questions, starts with a specific question. What specifically is the problem you are experiencing with your firewall? Okay. So it's like a question that can be asked by some maybe not exactly customer managed support. But some IT, let's say it can be a question that some IT specialist can ask employees. So what is the problem with the firewall? And then we've got supportive questions. Have you considered other methods to improve the security of corporate data? What do you think would make security more effective here? In general, how do you feel about the security of data versus the importance of internet access? So it starts the pyramid structure of questions during the interview. We are starting with a very specific question, and then we are broadening the area, finishing with a very general question. So how do you feel about the security of data in general in the organization? Another quite opposite structure of questions is the funnel structure. So the shape is exactly opposite, and this time we start with a general question. For example, what are your reactions to the new web-based procurement system? Then what departments are involved in implementing it, what items will be available for purchase on the website. Is there any essential item that has been excluded from the site? So we are starting from the general and we're finishing with the very specific detailed question. And we've got like compilation of these two methods, diamond-shaped structure of questions. When we start with specific question, we move toward general questions, but then we once again move towards specific question. Like in this case, what 5 kinds of information are tracked by the free website usage service you use? What are the promotional activities you feature on your website in exchange for the service? What is the value of the usage information to you as a webmaster? What are 2 surprising items concerning end user behavior on your site that you have discovered by using this service? Are cookies a better way to measure end user site usage? So we started with a specific question, then more general questions, and starting from the general perspective, we can direct the conversation, direct the interview in the way we want it to move. In interviews, we can have open-ended questions like, what do you think about, what is your opinion? Or closed questions, like how many client services good do you have? How many documents should you analyze per 1 hour, and so on. So we can have questions that allow us to, or actually allow an interviewee to express their opinion using their own language. They can be as general or as specific as they want. Having this let's say flow in conversation can lead to new threads and topics that we haven't thought about. But there is a risk that interviewer will lose the control over the interview. So if we got a lot of open questions, we never can perceive what will be the final outcome because we don't know in which direction our interviewee would go. Closed questions, answers are easy to interpret, analyze, and compare. Definitely, it's easier to interviewer to control the situation, but they are usually boring. And we may not touch all the topics that are important, for example, for the interviewee. So with closed questions, we don't have like the possibility to add something, to dig deep in some topics. So both questions have their advantages and disadvantages, and we always have to take them into consideration while gathering data using these methods for within our decision-making process. While finishing the interview, it is good to end with, is there anything we haven't touched on that you feel is important? Even if we won't use this information, it is very, very useful for us, very valuable information. Because based on this, especially at the initial stage of our of gathering data, we can, for example, modify our interview. add some questions or rephrase something. So definitely having this feedback from interviewee is very valuable. Focusing on disadvantages of interviews. As I mentioned, this is time-consuming method, generating high costs. It can be boring for interviewees. Information are prone to misinterpretation because, especially if we got open questions, the interviewer is the one who is interpreting the answers, the results. Interviewee can exaggerate or omit some facts, and interviewee can commit an error, intentionally or not. Definitely, these are the factors that makes this method, let's say, less used. And the solution to this problem may be a JAD technique, so Joint Application Development Technique. This is a popular fact-finding technique that involves all the users. User participation in the development process is active, and JAD sessions have a form of meeting. So, or let's say, stakeholders within a project, maybe this is the best word here, can influence the project during its creation. What kind of JAD participants we can have? We can have project leader, we can have top management in the enterprise. Maybe let's define the role of each of them. So basically, JAD project leader develops an agenda, acts as a facilitator, and leads the JAD sessions. Top management provide enterprise-level authorization and support for the project. Lower-level managers provide department-level support for the project and understanding of how the project must support business functions and requirements. So in solving what kind of problems the system should help us. Users provide operational level input on current operations, desired changes, input and output requirements, user interface issues, and how the project will support day-to-day tasks. So they will be basically the ones that will be using the system. So it is important to know what are the system requirements from their perspective. Then we've got system analysts and other IT staff members. They provide technical assistance and resources for JAD team members on issues such as security, backup hardware, software, and network capability. So they know what are the technical constraints. Recorder documents results of JAD session and works with system analysts to build system models and develop, for example, case tool documentation. Not always case tool. This is one of the examples of tools for projecting and documenting the information system project. So different participants with different roles. What are the advantages and disadvantages of the solution? Advantages: this allows to resolve difficulties more simply and produce better error-free software. The joint collaboration of different types of participants lowers all risks. Communication is very important in lowering the risk, because if we can identify the risks earlier, or potential conflicts or misunderstandings, then we are lowering the risk of the project and probably also managing properly the cost of the project. JAD encourages all participants to work better and faster and deliver the results on time. Definitely employees, if they have if an impression that their opinion is important, that they are important part of the team, they can work more effective. JAD sessions are good for requirements identification, definitely. Some time ago, I was asked by the financial manager at university to let's say review and propose a solution with some spreadsheets. There is the unit at university responsible for postgraduate studies. And this is, from one perspective, the organization within university, but it has its autonomy. But all the financial operations go through university. And they developed a spreadsheet to gather data important in the process of this financial management over the project. But it occurred when we finally met in some bigger group that they haven't discussed it in advance. So actually the spreadsheet they presented me didn't even contain the data they required. Because they required some data in different structure, like identification which payments were made by bank transfer, for example, which were made via direct payments from the website. And actually, this spreadsheet didn't contain this particular information. And this could have been avoided if they're communicated earlier, not when the project was ready, but before. So when we communicate, when we meet within the team that represents all different stakeholders of the project, then we can make effective decisions because we've got the data we need to make those decisions. Disadvantages of this method, basically the big role of leader that should be well prepared for controlling the discussion. So to avoid off topics and to focus on the problem we are to solve. And this technique also may expose some conflicts between members of the team. So the biggest disadvantage in this method is human factor in it. So the individual people who are involved in the project. Okay. I need to here. RAD approach, so rapid application development. This method uses a group approach. It's a complete methodology which can be used for system creation process. And it is composed of 4 pages: requirements planning, user design, contribution, and cutover. So the first stage, requirements planning, it involves user managers and IT staff, and they should agree upon business needs, project scope, and system requirements. And they need approval for continuing. So a lot of decisions that are to be made. business needs, project scope, system requirements. We need to define them, and then we can move to the next stage, which is user design. Interact with user, build models and prototypes, conduct intensive JAD type sessions. So rapid application development uses joint application development as one of the methods. Then we've got construction tasks, so program application development, coding, unit integration, and system testing. Basically, when we know what we want to create, what are the requirements, we can create it. And we've got cutover tasks like data conversion, full-scale testing, system changeover, and user training. These stages are very similar to the stages of system creation that we already mentioned during our previous lecture, like planning, designing, construction, and testing. Basically, these elements can be depicted here. This approach involves all users. It allows to reduce costs, and as the name says, it acts quickly. RAD sessions are focused on identification of users' requirements, not strategic goals, and may cause some problems with system quality, consistency, and achievement of long-term goals. Because if we focus on individual goals, then we may lose the bigger picture from our side. So if we focus too much on users, their goals, their needs, we may forget about the system needs as a whole. Then we've got surveys, very popular method for gathering data. Survey questionnaire, we've got a list of questions, but not asked directly in human-to-human communication, but by using some written question of different types, like long answers, short answers, some clarifications, but also some closed questions that are very popular in surveys. Here we've got examples of open-ended questions. Here we've got some examples of closed questions that can be used in a survey. Definitely, nowadays, the most popular are electronic surveys. It is definitely facilitated by the development of information technology. We've got special services for surveys. A lot of tools that we use in our everyday life also have support for creating and gathering data from electronic surveys. Basically, in both interviews and surveys, but more with the surveys, sampling is a very important action. Sampling is the selection of a subset, a statistical sample of individuals from within a statistical population to estimate characteristic of the whole population. What are the advantages of sampling? The cost is lower and data collection is faster than measuring the entire population. So assuming that we've got whole big population, I don't know, on all students in the world, and we want to make some survey. Of course, it is not possible to reach to every student at every university in the world. So we need to take some sample. And depending on what will be the characteristic of the sample, we can either estimate the results to the whole population of all students from all countries, or, for example, to population of students from a single country if we get our responses only from one country. So sampling is crucial, especially with surveys, when we can send a lot of surveys. And actually, the number of responses that we get is definitely significantly lower than the number of surveys we send. With interviews, we also can use sampling, but basically, when we decide that we want to make some interviews, we usually have some target interviewees in our minds. So, but basically, sampling also is used in in interviews. There are different ways of sampling. For example, here we've got random sampling. So from the whole population, we randomly pick some representatives for sending the survey. We've got systematic sampling. In this case, for random sampling, we just pick random elements from the sample. From systematic sampling, we randomly select the first element and the interval. In this case, sample is every third element from the population. So if we select randomly the first element, then we've got all elements then the next elements are like every third, every fourth, and so on element from the population. Stratified sampling, also one of the random sampling techniques. In this case, the values are sorted. We can see that previously we've got like different classes of objects of potential respondents to our survey. They were randomly placed. In this case, we've got elements sorted by certain category, and then from which category we pick up samples. Cluster sampling, we group our object into clusters, and then we pick clusters, not individuals directly. Document studies. This is another potential source of knowledge. Sorry. Document studies. Basically, this is also important part of gathering data, but the way it is done changed a lot within last few years. And this is the area where machine learning, artificial intelligence can be used. Because if we perform the document studies manually, it is very time consuming. So it generates a lot of costs, potential costs. But the new tools, often supported with machine learning, artificial intelligence algorithms, can analyze documents faster and sometimes more effective. So we can gather data from documents, even old ones, not only by manually reading the document and looking at its structure, at the data, we can also use some tools for automatic gathering information from documents. Another type of gathering data is observation. Basically, it is assumed that it is done by a human being, by a person. However, also nowadays, the techniques that we can compare to observation are more developed. We've got something what is called Internet of Things, which basically means usage of a lot of sensors. So basically, we've got artificial system, because IoT is definitely artificial system, that once again tries to mimic the natural system. Because using many sensors, we basically mimic the human senses, like watching something, listening to something, observing. Basically, observations done by humans, but we can also use some sensors, some other IoT tools to gather data with let's say without much human intervention in this process. Definitely in this presentation, there are not mentioned some other techniques for gathering data that uses some automation process. The biggest probably data source nowadays is internet. We can find a lot of information there. So while gathering data for analysis, from the perspective of organization, we can talk about internal and external sources of knowledge. In this presentation, I mentioned mostly external sources of knowledge. So how to gather information from our customers, from our partners, and other stakeholders of our business via survey, via interview, but also some discussion sessions that help us gather the required information. Some of them have, I like internal sources of knowledge, because if we gather information within our organization, these are internal sources of knowledge. But we can also download some data directly from the internet using either API interface directly from application to application, or by, for example, web scraping the data from the websites. So information technology definitely influence the way how we are gathering data, that are a very important factor in decision making. To make effective decision, to make the most effective decision, we need a full information within some topic. However, not always full information is available for us. But basically, any information we can gather, okay, no, not any information, but mostly the information we can gather should help us lower the risk of making certain decisions. There wasn't in this presentation, there wasn't mentioned the phenomenon of information overload. Because it may happen that we actually gathered too much information. And then the capability to make the effective decision goes down, basically. So if we don't have enough information, it's a bad situation. But also, if we got too much information, this is also potentially problematic. Structured approach in information in system analysis. We already mentioned with the system development the structured approach to system development. It can also be used in system analysis. And in structured approach, algorithms and data are separated. So we separately describe the data that we required, and separately describe the algorithms. That are to be used. Main tools that are used for structured approach in information systems development are data flow diagrams and dictionaries to represent data, and natural language block diagrams, also called flowcharts, pseudocode, decision tables, and decision trees to describe the algorithms. So separately data, separately algorithm. Data flow diagrams show how data moves from the information system, does not show processing steps, show what the system does, but not how it is done. We've got some symbols that we can use in data flow diagrams, like entities, data flow, process, and data store. We've got different notations. Here are the symbols elements from one notation, but we can basically use different notations, which are quite similar, as we can see. In this case, two Jordan symbols and Jean and Sarson symbols. Two different notations for the same diagram. We've got process, we've got data flow, data store, and external entity. Process symbol has a unique name, does not reveal a business logic, so it's a black box. Receives input and produces outputs, but we don't know how does it work in the inside based on the diagram. Data flow symbol represents a flow of a single data item or a set of data. Should have one or two arrowheads because we can have the flow in one direction or in both directions, and it should be labeled. Data store symbol represents data stored in the system. It doesn't show specific information about data content and structure. Data are produced and used by processes, not directly by entities or other data store objects. So we need a process to produce some data. Data store usually has input data flow and output data flow, because we can put data in the storage, but also take it from the storage. Entity symbol. Entity is identified by a name. Data flow diagram shows only external entities that provide inputs and received outputs from the information system. Entities play a role of terminators. Source entities produce data for the information system, and sink entities receive data from the information system. Correct and incorrect examples of data flow. Data can flow from process to process, from process to external entity, also both directions, and from process to data store. But we cannot have on our diagram flows between external entities, because if there is flow between external entities, this is not our field of interest, let's say. External entity to data store and data store to data store. This flows must lead via some process. So here we got few examples. Services performed, create invoice, and we produce invoice. Submit work. We've got process graduate student work, and output graded work student grade, and so on. These are incorrect examples of data flow. Apply insurance premium. We've got policy number, premium amount, so we've got some outputs, we have no input. Calculate gross pay, pay rate, hours worked, only input, no output. And date of birth, calculate grade, final grade. But having date of birth, we cannot produce final grade. So not sufficient or not correct, let's say, information is provided to the process, and then it also won't work. Here we've got examples of correct data flows, post payment, daily payments, repairs deposit. So we've got process, post payment, then we've got customer payment that goes to the daily payments data store, and from this data store we've got daily payment, repairs deposit. So this is one of the examples of correct data flows. So we've got process, data storage, and process. Once again, examples of incorrect data flows. So between two data stores, and we've got two other examples: post payment, customer payment, daily payment. And flow from passengers to book flight, flight request. Here, examples of correct uses of external entities in a data flow diagram. So we've got customer applied payment, prepared deposit, bank deposit, verify order, 2 directions, because we've got order from customer, but the process also sends the invoice. Employee, create paycheck, goes to employee, time card, also the correct flow. Once again, payroll department employee, paycheck. 2 external entities cannot be connected with each other. This connection requires some action. The data flow diagrams, they are layered. There are different layers of data flow diagrams. Context diagram, the whole information systems is presented as one process. Diagram 0 or 0 diagram shows the whole system with main internal processes, and lower level diagrams show details of one process or a group of processes. Here we got context diagram. So we've got all the elements here. We've got one process, we've got grading system, we've got 3 external entities, student record system, student and instructor, and we've got data flows between them. Zero level diagram is a more detailed diagram than the context, because here we've got not the whole system, but one of the subsystems. In this case, we've got grade student work, assigned final grade, established grade booked, grade book produced, grade report. So this is a description of data flow within a process aiming to grading students. So if it's a part of the system, this part is responsible for evaluation of students. Then we've got a different diagram level, 0 level. This time is about ordering. So we've got warehouse customer. Customer is making an order. There is an invoice payment. Except customer and warehouse, also sales department, accounting, and bank can be involved in this process. And then we've got lower level diagrams in which we present some part of the diagram in more detailed way. In this case, we've got customer, warehouse, we've got order, that are verified, and we can assemble the products from the warehouse from this order. What are data dictionaries? Data dictionary includes a detailed description of all elements represented on data flow diagrams, so entities, flows, processes, and data stores. How we can describe the process of the algorithm? Natural language, flowcharts, pseudocode, decision tables, and decision trees. Here is an example of algorithm described in a natural language. This is actually about opening a new bank account. So we've got instruction to open a new bank account. The customer first has to fill in the form, open bank account, hence The clerk collects the required documents and sends the form to the customer per mail. Once the response from the customer is received, the clerk enters the data from the form into the customer management system. So we've got the whole procedure, how to open a new bank account, and it is described in a natural language. Here we've got example of a flowchart. Actually, we are missing start and end elements in here. But basically, we've got problem. LAMP doesn't work. First condition is if LAMP is plugged in. If not, well, basically it requires to be plugged in to work. Then maybe bulb is burned out. If so, it has to be replaced. But if it's neither of this situation, we need to repair the lamp. Here we've got examples of actions with the rectangles and questions, conditions within diamond-shaped elements. Here we've got example of pseudocode. Pseudocode is, let's say, something in between natural language and programming language. So basically, it is written in something that resembles natural language, but we use some keywords from different programming languages here. Then we've got decision tables. Decision table shows every combinations of conditions and actions. It is a good tool when the number of combinations is relatively small. So we've got 2 conditions and 4 actions, and 1 element to be evaluated, policy or process name. So the policy or process, this is what we will be evaluating. Then we've got rules. Based on which the decision is to be made. So here we've got decision table for the process verify order with credit waiver. And we've got 2 possible options. Credit status is okay, product is in stock, waiver from the credit manager. And then, based on each criteria, we need to select if we should accept order or reject it. So we've got 3 parameters: credit status, product in stock, and the manual managerial approval. And based on this, on the domination of yes versus no, we count for each order. We need to accept or reject it. The similar, or at least a little bit similar situation we've got with decision trees. In decision trees, we based on making decisions. So for each question, we should have 2 answers, yes or no. So this is example based on sales promotion policy that showed in this decision table. Yes, no, a different decision table that is not depicted in the presentation. Decision tree show all combinations of conditions and outcomes. And the main difference between this table and this tree is the graphical format, which might be easier for user to analyze. So we've got first question, if it's our preferred customer. If no, then the basic bonus is $5. If yes, we need to check if he or she ordered more than $1,000. If no, the discount will be $25 in coupons. But yes, then we check if he or she used our charge card. If no, discount is 5%. If yes, discount is 5%, and there is additional discount also of 5%. So these were the methods connected to structural approach to system development. But the last part was rather about decision making with the support of the system. Then we've got structured system in which data and processes are separated, and in which we can implement in form of a simple structured algorithm with some conditions and some iterations, decision table or decision tree. The second approach to information system analysis, also approach that was presented as the approach in general to information systems, is object-oriented approach. Object is a model of a real entity or event. Objects are used for representation of people, places, events, transactions, and so on. Object has both attributes and methods. So in one object, we have both data and procedures. Object can perform a task, send a message. And in programming, we have two concepts, class and interface. Class is an object definition, represents common features of a set of objects. So we've got this data, but also same actions. Instance is an individual representative of a class. So sometimes we call it object of a class or instance of a class. In definition of the object-oriented approach-based system, the useful tool are UML language-based diagrams. The UML is a general-purpose developmental modeling language in the field of software engineering. It is used as standard for system visualization and design. Of course, it can be used for description of various types of systems. And here we've got like a structure of diagrams in UML system. We've got structure diagrams or behavior diagrams. For behavior, we've got activity diagram, state machine diagram, interaction diagram or use case diagram. And interaction diagram is divided into communication, interaction overview, sequence, and timing diagram. In the same time, structure diagram has elements such as composite structure diagram, class diagram, deployment diagram, component diagram, object diagram, package diagram, and profile diagram. Okay. Let's move to UML elements. We've got few UML categories, for example, category thing. And UML elements we can use to represent it are structural things like classes, interfaces, collaborations, use cases, active classes, components, and nodes. Behavioral things, interactions, state machines, grouping things, packages, additional tags, some nodes. These were things category. Relationships, we've got structural relationships and behavioral relationships. Structural are dependencies, aggregation, association, generalization. And behavioral are communication, includes, extends, generalizes. And then we've got diagrams. So we've got structural diagrams like class diagram, component diagram, deployment diagram, but also behavior diagrams, use case diagrams, sequence diagrams, communication diagrams, state chart, and activity diagrams. On this slide, we've got a picture that shows the connections between different diagram types. So we've got, for example, here use case diagram that can provide input to activity diagrams, class diagrams, use case scenarios, which also provide data for sequence diagrams. They exchange information with communication diagrams. Also, state chart diagram influences the class diagram. So we've got different diagrams with the flows between them. Already mentioned class versus, I mentioned class versus interface. Here we've got class versus instance, often called object. So we've got parent object, or actually parent class with attributes name, age, sex, hair color, and methods read bedtime story derived in the carpool. So we've got characteristics that describes the object and actions like methods. And then we've got instances of parent object. So basically, they depict real people described by the characteristics defined with the class definition. So we've got name, age, sex, hair color. So we've got Mary Smith, age 25, female, red hair. Ahmed Ali, age 34, male, brown hair. And Anthony Green, age 42, male with brown hair. So these are the exact instances of parent class. Here we've got, once again, class definition instructor with attributes, structure number, name, address, telephone, fitness classes, taught, availability, private lessons, fee, status. But also actions like teach fitness class, change availability, change address, telephone, private lesson, fee, or change status. This is example of UML class within class diagram. So we've got class name, attributes, and methods. Private and public components. In some languages, programming languages, I don't think I've seen it in Python. There are different access types to data and methods within class definition. Minus sign means that those attributes are private. So they cannot be directly called or changed. And plus means that the elements are public, may be invoked by other cases, but basically plus sign means that the elements are public, so even external function can change. Here we've got more detailed class description because all the attributes have also the data type assigned. Also, function names have information about input and about the data type. Here we got another class definition in which balance, class with an attribute value defaulted to 0. Yes, balance by default has value 0, and we've got two actions, deposit and withdrawal. Class inheritance. Often when we create a class, okay, maybe different. Let's start it different. For different classes, they may have something in common, some attributes or some actions. Like in this case, we've got a car, minivan, truck, and school bus. And they all are vehicles. So they've got some attributes and actions in common, like make, model, year, weight, color, method, start, stop, park. These are the methods that all the cars have, or the vehicles, like car, minivan, truck, or school bus. So we can say that the vehicle class is a generalization for other car classes. It doesn't mean that we cannot have like individual attributes, because for example, for truck, we've got load limit, additional attribute, and for school bus, emergency exit location. These are some additional attributes, except from the 5 defined for all vehicles. Similar, but with employee. Employee can be a manager, office staff, and instructor. Also, we've got common attributes and uncommon attributes, and in this case, we've got only common methods. In this case, we've got not only uncommon attributes, so we've got person. Person can be employee. An employee can be instructor. So we've got like 3 levels. Let's say that employee is our class, then we've got superclass, which is something more, it's person. And we've got something, maybe let's not say less, but not full employee, or sometimes more than employee. Because instructor has its own attributes like instructor type, availability, and methods, teach fitness class. So basically, instructor has all the employee attributes and methods and something more. And employee has all the person attributes and methods. To depict inheritance in UML, we've got this wide open arrow. Here are the example in UML. Focusing on communication between system elements. Instructor object sends message to student record and the message is enter grade. So we can name the relationships between entities. Relationships between classes. Graduate student has thesis. Graduate student class with its data and methods. Thesis also class with data and methods. But we need to define how many graduate students are assigned to one thesis and how one thesis is connected to graduate students. What is the multiplicity? And here we've got one-on-one. So one thesis is assigned to one graduate student. One graduate student has one thesis assigned. But there are other multiplicity options. And the same notation, the same type of values are used when we talk about databases and storing data. Here we've got multiplicity explained. So 0 or 1, 1, 0 or more, 0 or more, 1 or more, 3 only, 0 to 5, 5 to 15. So these are the multiplicities that we can use. Once again, relationship between classes, student, course. Student can be enrolled to many courses, like you are choosing courses. And it should also be information for how many courses, how many students can be on one course on this diagram. Here we've got class diagram for a sales order use case. So first we had use case, and then we present the data and methods for each entity on class diagram. So we've got sales manager, sales representative, sales office, customer order, and items ordered. These are the classes with their attributes, methods, and relationships. There is something that I was actually surprised that wasn't put in here, because basically one student can attend many courses and there are many students on one course. So basically here we should also have one to many. And here we've got some example of association class. So the class that represents the relationship between two other classes, like person and committee. It is represented by membership. So one person can be a member of many committees, and definitely one committee consists of many people. And being part of a committee is called a membership of this committee. So we've got this association class that tells us, holds the information about the relation between other entities. Aggregation is one of the relationship types in a class diagram in UML. In this case, we've got with association, car contain wheels, but wheels can exist without car. So that's why in this case we use association. So they are connected. Wheels are some part of a car, but not integrated to the level that they cannot exist separately. Here we've got stronger relationship, which is composition. In this case, department belongs to a company, and we cannot have department without a company. It doesn't exist except from the company structure. So that's why here we used composition as a relationship stronger to the previous one, which was association. Class may be associated to itself. So we've got reflexive association, sometimes connected with recursive in programming. Because we've got employee who can be either a manager or who can be managed by the manager, which is also an employee of a company. In object-oriented approach, there is a very important concept of polymorphism. So, for example, we've got message good night, and it can be interpreted in a different way depending on the class in which it is defined. So we've got the same function, but with different actions. For parents, it will be, for example, reading a bedtime story. For dog, it would put dog to sleep. And for child, for example, it causes the child object to get ready for bed. So we've got the same name of a message, good night, but for different classes, different object, it will produce a different results. Use case diagram shows the interactions between external actors and information system processes and functions. So for example, we've got patient, actor patient, and we've got use case, which is make appointment. Here we've got a little bit more complex, let's say, more complex than the previous one system. In restaurant, when we've got food critic who can eat food, pay for food, drink wine, and we got chef who cooks the food. So we've got two external actors, food critic and chef, and we've got in this case 4 use cases: eat food, pay for food, drink wine, and cook food. Using UML, there is also something like extends. So we've got customer and bank employee. Bank employee can help customer in opening account. Customer can deposit some funds, and if he or she want to gain money, they can calculate what will be the bonus. So calculate bonus is probably part of the deposit funds, it extends it somehow. And provides a useful information in decision-making process. Here we've got comparison between extends and include. For extends, this is the weaker, let's say, relationship, because deposit funds, we can calculate bonus within a deposit funds, but we don't have to. But if we got include, like deposit funds or withdraw funds, it includes updating the balance. So we have to update the balance if we deposit or withdraw funds. But if we deposit funds, we don't have to calculate balance. We have it here, but this is not like a visible option in this case. Here we've got travel agency for actors, travel agent, customer, airline company, and touring company. And we've got, we don't have arrows, so I don't know what is the, we've got book airline tickets. And what extends what? I think book a tour extends book airline tickets, but I'm not so sure about the arrows. Airline company reserve a seat, deliver airline tickets, arrange tour, pay travel agency, include travel agency commission, pay for airline tickets, pay for tour. So different use cases and actors that are associated to them. The use case diagram for ATM, so money withdrawal. Cardholder can order checkbook, cancel transaction, view balance, withdraw cash, or start decision. While bank employee by default can deactivate ATM and print audit log. Once again, use case diagram. This times we've got actors like student, registration, financial office, bookstore, department. Oh, and one more student. And we've got actions like add student, verify identity, enroll to classes, purchase textbook, transferred credits, view student information, change student information. These are the use cases we've got on this diagram. Activity diagrams. Description of activity defined in a use case diagram. So each use case may create one activity diagram. Here we've got like 1, 2, 3, 4, 5, 6, 7 use cases. So each of them can produce an activity diagram describing its structure, the activities taken within it. We can use, for example, flowchart to describe the activity, like calculate total cost, and if cost is less than $50, charge customer's account. If cost is more than $50, get authorization. Having a flowchart or any chart of this type, in this case, we've got the decision problem. We've got one input, two outputs, and we need to make the decision. We can also have like merge activities, many inputs and one output. So these are the two different types of flows we can have within activities. In this case, we've got other elements of activity diagram, specialized symbols that we use. We've got start and end. We've got fork that divides the whole process into two sub-processes. And we got join, so the synchronization bar that works and as an opposite to fork, because it gathers information from different, gather flow from different subflows on this diagram. Here we've got another more complex example. And next type are sequence diagrams. Sequence diagrams presents the time aspect of communication. We've got object of one class. We've got object of second class. There is some communication between these objects. Here depicted as a messages that are sent from one object to another. And also we see the creation of second object, but also its destruction. Once again, sequence diagram, so time aspect of communication, and very important communication diagram. And here is a relationship diagram for the fitness center. We've got students who takes fitness classes. We've got registration record to which we added student. Registration record generate roster for fitness classes. But we also have manager that determines the fitness classes schedule. Office staff that administers the registration record, and instructor that indicates availability. And those three managers, staff, office, and instructors, they are employees. This is a little bit different communication diagram for students admission. They show basically the same information as the sequence diagram, but it emphasized the organization of objects rather than time ordering. So in time, in time diagrams, the time was the crucial thing. Here in communication diagram, the crucial thing is organization of objects within the structure. So we've got students, we've got new student interface. So new student interface initializes, so creates students. Student also selects a program and selects dormitory. State chart diagram. State chart diagram illustrates the event-driven state change of a system. Shows the reaction of a system to internal or external factors. So we've got some action, and we need to check how each action influences the whole system. So we've got enrollment. What happens if course is in progress? If the course was cancelled, that's it. If the course is in progress, student is dropped, then we've got final exam, which leads to completing the course. New game, win state, lost state, and end game, also state chart diagram for another another system. Agile approach. We already discussed this agile approach. 1 second, I just check. Yeah, we are basically, okay, I know at which stage we are. So we already mentioned agile approach to creating information system. And here we've got one of the agile approaches, Scrum framework, like on one diagram, summarized on one diagram. So the product owner is a member of a team that gathers inputs from executives, teams, stakeholders, customers, and user. So product owner is a person within a team that is responsible for communication with different stakeholders, but also with the team. And it prepares the requirements for the project. Team select starting at top as much as it can commit to delivery by the end of the sprint. So basically, we've got the features ranked, and we are not doing the whole system at once. But as we already mentioned last week, we choose one feature, probably the higher ranked one, and in some short intervals called sprints, we try to deliver a certain feature as a team. And the duration of the sprint is 1 to 4 weeks. So this is the time we are giving ourselves to finish certain feature and produce finished work. And each sprint consists of every 24 hours daily Scrum meetings that should lead us to solving the problem, to creating the system that we need. So this is like Agile Scrum framework summarized at a glance. What are the advantages of Agile approach? Definitely, it is more flexible and efficient in dealing with change. So we have the opportunity to react to change. It enhances team interaction and community-based values. And it also reduces project risk. With risk management, we mentioned that communication is crucial. If we detect the problem soon enough, we can reduce the risk. Disadvantages: team members need a high level of technical and interpersonal skills because it is based on communication once again. Lack of structure and documentation can introduce the risk factors. This is like the misinterpretation, let's say, of Agile approach, because basically also Agile approach can produce a documentation, but it definitely looks different than when we document Mm, the system in a more classic like waterfall method can introduce significant and misguided changes in the project. Sometimes when we focus too much, we also mentioned this risk. When we focus too much on the user goals, and when we have communication with the users mainly, we can lose the main goal from our side, and then it may cause the misguided changes in the project. So these are the advantages and disadvantages of agile approach, and basically this is the end of this first part, focused on the system theory as it was mentioned in the description of the course. So we started with a general definition of a system, but this led us to information system, which is a tool within organization that should help us to solve the problems and support us in making decisions. For a few minutes, I can stop sharing my my screen. There are different types of information systems with their different complexity. The biggest information systems like ERP class system, they contain different modules. And one of the modules that we can find, or one of the types of information systems, if it's not the modular one, are decision support systems. So those are systems that should provide the management information required to make effective decisions. Another type of information systems that are very useful in decision making are business intelligence systems. And business intelligence systems uses the machine learning, artificial intelligence, the most from all others components of information systems in enterprises. Basically, how decision-making, problem-solving in organization looks like. Usually, in organization, we start with the when we met some problem that needs to be solved, and the problem can have different nature. It can be connected to different areas of enterprise operation, to different departments. The problem can have different scale, but usually to solve the problem, we need to make a certain decision. So decision making is connected often to problem solving. Not only, but usually we can present different, let's say, different actions or different situations as problems to be solved. Because even if you are making a decision about, I don't know, for example, introducing new information systems, as we already mentioned during this course, we can start with defining as a problem that, for example, our current system is not sufficient, or we don't have information system that supports our organization. So this is our problem, and we need to make the most informed decision about introducing new system, or we have to make a decision about the expanding existing system or any other decision. So we usually start with some problem of different type, different kind. And then the next step is defining what kind of decision we have to make in order to solve the problem. When we know what kind of decision we are to make, the next step is usually analysis what kind of information we need to make this decision. What factors influences our decision? And then we can operationalize this process. I probably haven't mentioned in my presentation the data, information, knowledge, wisdom structure, so wisdom pyramid. But it depicts, I probably don't have it on the slide, but it depicts the structure of those four concepts, which are very important in information technology. We use the concept information technology actually more emphasizing the technology aspect. But probably it was mentioned when I mentioned the history of the theory of systems concept. I've mentioned cybernetics and other, let's say, ancestors of modern information technology. And basically, it all started with the information. It is all focused on exchanging information, on allowing computers to store information. If we see this knowledge pyramid, data, information, knowledge, wisdom, at the bottom of it, we've got data. Today, we mentioned data gathering from different sources. So basically, computers or other electronic devices, like also sensors, are able to collect data. They operate on data. Simple signals that are like, for human beings, they individually, separately, they have no meaning. Because we as human beings exchange information. So the key thing in information system, one of the key things while developing information system is to modeling information into form of data, complex data structures that we use to gather information and exchange information in computer systems. And that's why we talk about information technology, because it's technology that allows us to store, to gather, store, transform, calculate, make operations on information that is represented in a form of data on computers. So we as human beings exchange information to gain our knowledge. And we use for accumulating the knowledge, We use new information that we got from the outside. We use our existing knowledge, but we also use our intelligence to accumulate the new knowledge. Wisdom is an ability to use the knowledge that we gathered. So, for example, we can have people who have a great knowledge, but not always know how to use it. And sometimes we can have people who maybe don't have the greatest knowledge, but they know how to use the knowledge they possess. So these are the two separate things, knowledge and wisdom. And part of the topic of this course is artificial intelligence. So why do we need artificial intelligence in computer systems? Well, basically, so that the computer systems can gain knowledge, that they can process the set of information in a form of data and create a useful knowledge from it and present it to us, that we also expand our knowledge. So modern computers, they can store and analyze in a form of complex data structures, sometimes very complex data structures, not only information, but also knowledge. When I presented, I also mentioned it today when I was briefly going through the slides from the previous presentation. I mentioned ontologies, which are one of the ways to store knowledge in computer systems as a relationships, as a structure, picturing concepts and relationships between those concepts. And this is one of the data structures that can be used with the machine learning, artificial intelligence approaches. So the first, we had to find a way how the computers can store knowledge. But even a few years ago, computers definitely could store the, let's say, domain specialized knowledge that we can present in the form of concepts and relations between them, definitely. But our knowledge is not only like the scientific knowledge we gain at school during studies by gathering information. The human being's knowledge comes also from the experience. We basically create our knowledge with all of our senses. Touching, hearing, seeing something. And a few years ago, it was more difficult for computers to gain, let's say, this experience. Because if we say that computer can experience something, we are personifying it. Because like only human being can sense something. We are using our senses to know the world. But definitely the development, for example, of IoT techniques influences the type of knowledge, let's say, that computers can have. Because the sensors in IoT, for example, can mimic our senses. Because they register, for example, the temperature, the humidity. The IoT systems that have cameras can register images. So these are the tools that allows computer systems to gather data that actually resembles the experience that human beings have while using their senses, how they perceive the world that surrounds us. So even a few years ago, we would probably say that the computer systems can store mainly domain knowledge that can be presented in a written form, in the form of some schemas, diagrams. Also, few years ago, probably, we structured the data before saving them in computer systems. But a few years ago, probably even at the end of the previous century even, more and more data was stored in a form of unstructured text. And the big part of information information technology is focused on natural language processing, so that computers can analyze data information that are encoded in some written forms, like text documents. So this is another step for the development of machine learning, artificial intelligence methods, also in the process of problem solving and decision making. Why? Because with the development of information society, the information become a good that can be bought, that can be sold, and in many cases, it can bring us the I've lost my word. Competitive advantage over our competitors. So we can gain by gathering information from different sources. We can gain the competitive advantage in our business. So gathering, analyzing, in processing information become crucial for many organizations in order to solve problems and make effective decisions. However, if the information is a good that we can buy or sell, it also means that the information that we can easily get won't give us this advantage. So the techniques for gathering additional information from big data sources to actually get information that comes from analyzing the data. So not the data itself, but the information that comes from analysis of data became important for organizations. So we now have like big data. So we got data that are characterized with the high volume, high velocity, high variety, and manual analysis is impossible. So we've got to have some tools that will allow us to analyze those big data in order to give managers the information that they can use to make effective decisions to gain the competitive advantage. So we've got different data sources, different types of data, especially large data sources like big data. And we can analyze them using different machine learning, artificial intelligence techniques. So we still have some time. Next meeting within this course we've got tomorrow and the day after tomorrow. I thought about two practical approaches, especially connected with decision making and problem solving, that we can use. I haven't decided which topic we will cover tomorrow, which on Friday. But the two topics I have in mind are multi-criteria analysis, which is a very useful tool in decision making. So when we've got few options from which we have to choose one, definitely, usually we have many criteria that we can take into consideration. And those methods allows us to rank our solutions in the way that can help us choose the best option for us. And this is one of the methods with some also theoretical background to describe how the method works. Probably we will do first some some calculations in Excel spreadsheet to show how the method works. And the second step will be a short script in Python. Okay, I need the... Oh, here I've got the chat. Sorry. Okay, definitely the both meetings are recorded, and I will. Okay, I was supposed to do it within last week since the meeting about the slides, because the slides I already presented. They are, as you could see, ready. The slides, because this last part of today's classes, the one after the presentation, I probably in some different places have a slides for this part. I rather had like my scenario for the for what I want to share with you. I was supposed to ask the organizers from Rijeka University what are the ways of providing you the data. I'm sorry I haven't done it since last week. My only explanation is that on Friday I had my PhD thesis defense, and this took a lot of my time. But definitely I'm writing the task for today. Check how to provide you with the presentation. how to provide the materials, because this will be also important for tomorrow and Friday classes, because probably I will share with you some data for our analysis. So I will check it, and for tomorrow definitely I hope I will have the solution. They usually respond very quickly. So the one method I would like to discuss and practice with you will be multi-criteria analysis. And the second topic, probably less practic in the way of calculations, but maybe we will have time for it. But I would like to mention within this subject something what was actually a topic of my PhD thesis, which is sentiment analysis and how it influences the decision-making process within organization in terms of marketing, but also in terms of product development. So the structure, what kind of analysis sentiment analysis is, I don't know if you've heard about this topic or not. And if you're interested in it, but for me, it's a very interesting topic of how people's opinions that are available in the internet, so we have access to it, how they can change both customers' decisions and enterprise management, marketing, production strategies towards their products. Multi-criteria. And opinion mining. Okay, these are the two practical topics I would like to cover during our next two meetings within this course. Probably we'll start with multi-criteria analysis tomorrow. It will be, I think, shorter, because tomorrow we got 2 hours, and on Friday we've got 3 hours. So yeah, probably this will be the order in which I would like to take these topics. And in opinion mining, probably for the opinions, maybe we'll analyze the opinions. Also in Python, we could check some models in Python for this purpose, but it will take us probably some more time than multi-criteria analysis. So this would be the structure of the topics. Okay, the previous classes and most of today's classes, because we've got like about 20 minutes left, were some theoretical introduction, a lot of theory, a lot of concepts. Maybe you've got some questions to the topics I've mentioned. We can have this remaining part of today's classes for your questions, if you have any. No questions. I was hoping because somebody was starting writing something. No questions. Everything clear and obvious. Okay. Can check if I have. I don't want to start the new topic because I'm not sure who will be present tomorrow, and I wouldn't like to repeat the beginning because it would be like probably waste of our time. And we haven't done any break within our classes, so if you have no questions, I've finished the presentation I've got prepared for this this part of this let's say more theoretical part about the system theory, about the problem solving and decision making. Let's say placement within information systems in organization, about data, information, and knowledge in information systems. What is necessary to gain the competitive advantage in information society? So not only access to data, but also effective analysis of this data, gathering information that can help managers making effective decisions to solve problems that organization is facing, or challenges that are in front of it. And I think that if probably organizers are with us, is it possible that we, for example, finish earlier today? We didn't have a break. We have like 2 hours and a half, almost 2 hours 40 of constant classes. So I hope that we can today finish a little bit earlier and continue with the topic. As I mentioned, multi-criteria analysis tomorrow and opinion mining on Friday. Thank you very much, Sandy. If you are with us, I also have a questions about sharing presentation with the with students because they asked about it. Do we have any way of sharing it? Should I send it to you or? Okay, okay. So I will be informed about it. About how to share information with you. So we are taken care of by the organizers from Riga University. So from my side, that will be it for today. Tomorrow we start at 2 p.m. and we've got 2 hours of classes, more practical, and then the last meeting is on Friday. We are starting at 1 p.m. 3 hours of classes, also more practical approach, selected methods for supporting problem solving and decision making within organization. So thank you very much for your today's attendance, and hope to see you tomorrow during next meeting within this course.
Thank you so much.